close your eyes and let me take you to a moment in time when Earth broke its own rules. It's 540 million years ago, and the water around your ankles is warm, crystal clear, and stretches endlessly toward horizons unmarked by any continent you'd recognize. Beneath you, the seafloor appears almost barren, covered in nothing more than bacterial mats that ripple gently in the current like living carpets. But something is stirring in the depths. Something that shouldn't be possible according to everything we understand about how life changes and grows. You can feel it, a subtle shift in the chemistry, a tremor of possibility that's about to unleash the most explosive period of creativity in Earth's history. In the next 20 million years, these seemingly empty seas will birth nightmares and wonders that defy every rule evolution has followed for the previous 3 billion years. Creatures with 5 eyes arranged like a crown will hunt through waters that have never known predators. Things with grasping arms and alien geometries will crawl across seafloors where only simple, soft-bodied organisms have ever dared to exist. Life forms so bizarre that when we find their fossils today, paleontologists stare at them and whisper the same question: how is this possible? Evolution is about to lose its mind. In a span of time that represents less than 0.5% of life's history on Earth, it will create more new body plans, more experimental designs, more fundamental innovations than in all the eons that came before. And despite decades of research, hundreds of theories, and some of the brightest minds in science, we still don't know why. This isn't your typical science video. It's designed to help you unwind, to let your mind drift, and yes, maybe even to fall asleep. But your brain doesn't stop working just because your body is ready for rest. While you're settling in, letting go of the day, you'll be absorbing something remarkable. You'll experience what it feels like to witness the moment when life on Earth decided to get creative, when the slow and steady rules of evolution were thrown out the window in favor of an explosion of experimentation that still shapes every living thing around you. So, settle in, get comfortable, and let your curiosity carry you to a time when Earth became an alien planet, populated by creatures that look like they were designed by minds that had never heard the word impossible. And let me know in the comments what draws you to these ancient mysteries. Are you fascinated by the moments when life took dramatic turns? Or do you just enjoy falling asleep to stories that make you wonder how many times Earth has completely reinvented itself? Now, get comfortable, dim the lights if you'd like, maybe grab something warm to drink. And let's drift back to those ancient seas where evolution was about to break every rule it had spent billions of years carefully writing. To understand why the Cambrian Explosion terrifies scientists, you need to understand the rules it broke. Rules that had governed life on Earth for over 3 billion years with the reliability of a Swiss watch. Our journey begins in Darwin's library in 1859, watching him sketch his famous tree of life. One trunk, branching slowly into 2 limbs, then 4, then 8, each split taking millions upon millions of years. This is how evolution works, he reasoned. Gradual change, incremental improvement, species slowly diverging like the branches of an ancient oak growing towards sunlight. The math of normal evolution is almost boringly predictable. Take the horse. 50 million years to go from a dog-sized creature with multiple toes to the single-hooved animals we know today. 50 million years for what amounts to losing some toes and getting bigger. Or consider whales. 30 million years to transition from land mammals to ocean giants. Each step in the fossil record shows tiny modifications, barely perceptible changes that accumulated over geological ages. This is evolution's normal pace, conservative, methodical, each innovation tested thoroughly before being passed to the next generation. Wings don't appear overnight. Eyes don't pop into existence fully formed. Complex nervous systems don't spontaneously wire themselves during a single geological period. But this is where the Cambrian Explosion becomes genuinely disturbing. In 20 million years, a time span that represents less than 0.5% of life's history on Earth, evolution created more fundamental body plans than in the previous 3 billion years combined. Let me put that in perspective for you. If Earth's history were compressed into a single year, the Cambrian Explosion would last approximately 12 hours. In those 12 hours, life went from simple, soft-bodied organisms that had dominated the planet for months to an alien zoo of creatures so bizarre that paleontologists are still discovering body plans that don't fit into any modern category. 20 million years to invent eyes, nervous systems, shells, claws, predation, defense mechanisms, complex behaviors, and body architectures so varied they look like the fever dreams of a science fiction writer who never learned the meaning of the word restraint. Standing here in those ancient seas, watching evolution suddenly abandon billions of years of conservative policy, you'd witness something that shouldn't be possible. It's as if life itself had been holding back, waiting for some cosmic permission slip to finally show what it was really capable of creating. But the problem is, we still don't know what gave evolution that permission slip, or why it chose exactly that moment to tear up its own rulebook and start over. 20 million years have passed, but the world has become unrecognizable. The water around you churns with life forms that look like they escaped from a nightmare designed by evolution itself. Meet Anomalocaris, the ocean's first apex predator, 6 feet long in a world where everything else measures in inches. Its name means strange shrimp, which is paleontologist talk, for we have absolutely no idea what this thing is supposed to be. 2 massive appendages extend from its head like grappling hooks, each one longer than your arm, designed to grab prey and stuff it into a circular mouth lined with razor-sharp plates. This creature represents something that shouldn't exist according to evolutionary timelines. Building a 6-foot predator from microscopic ancestors should take 50 million years of gradual scaling up. Anomalocaris did it in 5. It's as if evolution suddenly discovered the concept of ambition and decided to test it on the most ridiculous design possible. But Anomalocaris looks almost reasonable compared to what else is crawling around down here. Opabinia approaches through the murky water, and your brain struggles to process what you're seeing. 5 mushroom-shaped eyes arranged across its head, like some alien crown. A long, flexible proboscis extending from its snout, tipped with a grasping claw that opens and closes like a tiny hand. Its body ripples with fins that seem attached almost as an afterthought, as if evolution was just experimenting with the concept of appendages and decided to try everything at once. When paleontologists first reconstructed Opabinia, they stared at their drawings in silence. This was evidence that evolution had temporarily lost its mind and started designing creatures based on fever dreams rather than functional necessity. Swimming past you comes hallucigenia, and now you understand why scientists gave it that name. Covered in defensive spines that jut out at impossible angles, supported by 7 pairs of stilted legs that make it look like it's walking on biological chopsticks. For years, paleontologists couldn't even figure out which end was the head. They reconstructed it upside down and backwards before finally admitting that evolution had created something so bizarre it defied their ability to understand basic anatomy. Each one represents evolutionary innovations that should have taken tens of millions of years to develop. Eyes alone should require 20 million years of gradual light sensing improvement. Complex nervous systems need similar time spans to wire themselves properly. Defensive armor, predatory appendages, sophisticated locomotion systems. Each innovation represents a massive leap in biological engineering. Yet here, in these ancient seas, all of these innovations are appearing simultaneously, as if life had been saving up its creative energy for billions of years and decided to spend it all at once in the ultimate evolutionary shopping spree. Wiwaxia scuttles past on the seafloor below, covered in an armour of scales and spines that don't match any modern animal classification. Its defensive systems combine features that evolution normally keeps separate. Mollusk-like scales mixed with worm-like spines, creating a creature that looks like it was assembled from spare parts belonging to entirely different phyla. Standing in this underwater alien zoo, watching creatures that shouldn't exist interact in ways that violate everything we understand about predator-prey relationships, you begin to grasp the true scope of what happened during the Cambrian Explosion. Evolution went completely experimental, trying out body plans and biological architectures with the reckless creativity of an artist who suddenly discovered unlimited supplies and infinite canvas. But the real mystery isn't what evolved during these 20 million years. The real mystery is what triggered evolution to suddenly abandon 3 billion years of conservative design philosophy and start building monsters that look like they were conceived by minds that had never heard the word impossible. Fast forward to 2024. You slip into the back of a university conference room. The air hums with the low buzz of whispers, laptops clicking, and the faint scratch of markers on a whiteboard. At the front, some of the world's leading evolutionary biologists stand frozen, staring at equations that refuse to make sense. For more than a century, they've been trying to untangle the Cambrian puzzle, and every new theory only seems to make the mystery deeper. The oxygen theory was the first attempt at an explanation, and it sounds reasonable until you examine the details. The idea is simple. Complex life needs oxygen to power complex bodies. So when oxygen levels rose in the oceans, evolution finally had the fuel it needed for larger, more sophisticated organisms. But here's the problem. Oxygen levels during the Cambrian weren't just rising steadily, they were fluctuating wildly, spiking up, crashing down, spiking again in patterns that should have stressed life into extinction, not encouraged it to get creative. Other periods in Earth's history saw similar oxygen increases without triggering evolutionary explosions. Why this time? Why then? The climate change theory followed, suggesting that the end of Snowball Earth, a period when the planet was essentially a frozen ice ball, created new environmental opportunities that life rushed to fill. Imagine the relief of life forms emerging from a global deep freeze into a world of warm, open oceans ripe for colonization. Except Earth has experienced multiple ice ages throughout its history, some even more severe than the Snowball Earth period. Life bounced back from these other climate catastrophes without suddenly inventing eyes, nervous systems, and predation. The timing feels too convenient, too perfectly aligned with the Cambrian explosion to be mere coincidence. Then came the arms race theory, and this one seems to make intuitive sense. Once the first predator evolved, prey animals needed defenses. Once prey developed shells and spines, predators needed better weapons. An escalating evolutionary arms race that drove rapid innovation on both sides. But this theory creates a chicken and egg problem that keeps paleontologists awake at night. Which came first? The predators that force prey to evolve defenses, or the prey that gave predators something to hunt? The fossil record shows both appearing simultaneously, as if someone rang a bell and announced that the age of peaceful coexistence was officially over. The genetic complexity theory suggests that sometime before the Cambrian, life developed the genetic toolkit necessary for building complex bodies. Hox genes and other regulatory networks, the molecular machinery that coordinates how eyes, limbs, and organs develop. Once these genetic tools were available, evolution could finally build the creatures it had always wanted to create. This theory feels more promising until you realize that some of the simplest organisms on Earth today have genetic systems just as complex as anything that evolved during the Cambrian. The tools were apparently available long before the explosion began. So why did life wait so long to use them? Each explanation reveals the same frustrating pattern. Every theory that seems to solve the Cambrian puzzle creates new questions that are even harder to answer. It's as if the more we learn about this period, the more mysterious it becomes. From the back of that conference room, as you watch scientists wrestle with equations that refuse to balance, the weight of the Cambrian explosion settles on you. It's paleontology's most stubborn mystery. The fossil record from this period is unusually rich, layer after layer preserving creatures in astonishing detail. We can see exactly what unfolded. But the deeper question, the why, remains out of reach. And that's what haunts the field. The unsettling possibility that paleontologists have been asking the wrong question all along. You stand at the edge of a cliff, staring down into what was once the floor of an ancient ocean. The rock beneath your boots tells a story that makes your head spin. Just below, the stone lies smooth and uniform, the quiet signature of a world locked in ice for millions of years. But just above that boundary, everything unravels. The layers turn chaotic, packed with the fossilized remains of creatures that seem to have burst into existence out of nowhere. This is the razor-thin divide between the end of Snowball Earth and the dawn of the Cambrian Explosion. And standing here, you can almost feel it, that instant when a frozen planet cracked open and began experimenting with life. Snowball Earth had turned the planet into a giant ice cube for nearly 100 million years. Imagine an Earth where glaciers stretched from pole to pole, where oceans froze solid except for a few scattered pockets of open water. Life clung to existence in whatever warm refuges it could find. Volcanic vents, underground springs, tiny patches of liquid water beneath miles of ice. Then suddenly the ice melted. Carbon dioxide from volcanic activity built up in the atmosphere until it triggered a runaway greenhouse effect that turned Earth from an ice ball into a greenhouse in what amounts to geological minutes. The planet went from frozen wasteland to tropical paradise faster than life had ever experienced. You can see the evidence in the rock beneath your feet. Carbonate deposits that formed when the newly melted oceans became supersaturated with minerals. Strange chemical signatures that suggest the ocean chemistry was unlike anything before or since. This should have been the perfect trigger for evolutionary innovation. New environments, new opportunities, vast, empty ecological niches waiting to be filled. But Earth has been through other snowball periods without triggering evolutionary explosions. The Huronian glaciation lasted even longer, ended even more dramatically, and life responded by continuing to do exactly what it had been doing before. Simple, single-celled organisms maintaining their status quo for another billion years. So why was this snowball different? Why did this particular ice age ending flip some cosmic switch that sent evolution into overdrive? Now you're swimming through those newly thawed Cambrian seas, and something feels off. The water tastes sharp, metallic, the chemistry unsettled. Acidity rises and falls like a heartbeat as the planet's carbon cycle thrashes toward balance. Trace metals surge and collapse in unpredictable waves, carried by shifting currents as newborn continents shed their icy armor and expose raw rock to the elements. These chemical changes should have been stressful, possibly even lethal to early life forms. Instead, they seem to have triggered the most creative period in evolutionary history. It's as if life needed this chemical chaos, this environmental instability, to unlock innovations that have been dormant for billions of years. But correlations aren't causations, and the timing still feels too perfect. The the snowball Earth ended at almost exactly the same time the Cambrian Explosion began. That kind of precision would make any scientist nervous because it suggests cause and effect, but the mechanism remains completely mysterious. The Earth itself was restless. Continental plates groaned and split, tearing Rodinia apart and scattering its fragments across the globe. As land masses drifted, shallow seas opened up, warm, sunlit waters that became laboratories for evolution. Volcanoes thundered, painting the skies with ash and pouring strange gases into the air, tipping the planet's climate into wild new rhythms. Rivers carved through raw, exposed rock, bleeding nutrients into the oceans and feeding an explosion of life waiting to happen. All of these environmental changes created new opportunities for life to explore, new ecological niches to fill, new challenges to overcome. But opportunity alone doesn't explain innovation. Earth has experienced plenty of environmental upheaval throughout its history without triggering evolutionary explosions. You wade through those ancient waters, watching as the first true ecosystems knit themselves together from chaos. Plankton clouds drifting, strange forms crawling across the seafloor. But as you take it in, a deeper question presses at the back of your mind. It feels like more than just climate shifts and drifting continents at work here, as if some hidden catalyst was waiting, something that transformed opportunity into explosion. The predation pressure paradox becomes inescapable. Predators evolved because prey became worth hunting, but prey only became worth hunting because they developed energy-rich bodies to escape predators. The chicken and egg problem spirals into repeated loops that make your head hurt. What if the trigger wasn't environmental at all? What if it was informational? Some breakthrough in how genetic information could be processed, stored, or expressed that suddenly made complex body plans possible. But that just pushes the mystery back one level. What caused the informational breakthrough? Why then? Why not 100 million years earlier or later? The real question hanging in these ancient waters isn't what happened during the Cambrian Explosion. The real question is whether this was random chance, or whether Earth was following some deeper pattern that we don't yet understand. Let me take you inside a laboratory, where a biologist peers through a microscope at something that shouldn't exist. The place is MIT. The year is 2024. E. coli bacteria have evolved to digest a nutrient that doesn't exist in nature, an entirely artificial food source. And they did it in just 33,000 generations. To Darwin, this speed of adaptation would have seemed unthinkable. Yet, here it is, unfolding in real time under controlled conditions. Evolution, it turns out, has gears we never imagined. For years, we thought of it as glacial, small tweaks stretched across eons. But the Cambrian Explosion taught us that evolution has a turbo mode, and today's experiments are hinting at the conditions that can unleash it again. Step outside the lab, and you see it happening in the wild. Cities have become pressure cookers. Peregrine falcons nesting on skyscrapers have developed hunting techniques, specifically for navigating between buildings at high speed. Their wings are measurably different from their rural cousins after just decades of city living. London's underground mosquitoes have become a genetically distinct species in the 150 years since the subway system was built, evolving to hunt humans instead of birds in the perpetual darkness below the city. But these are minor adaptations compared to what's happening in agricultural systems. Pesticide resistance doesn't evolve gradually over centuries. It appears in insect populations within single growing seasons. Herbicide-resistant weeds spread across continents in years, not millennia. When survival pressure reaches critical levels, evolution responds with speeds that would have seemed impossible based on fossil evidence alone. You push your way through a cornfield in Iowa, the stalks towering above you, leaves brushing against your arms. The air smells faintly sweet, the soil damp beneath your feet. It feels timeless. But what you're surrounded by is one of the boldest evolutionary experiments in Earth's history. 10,000 years ago, there was no corn, only teosinte, a scraggly grass with seeds no bigger than grains of rice. Human artificial selection transformed it into something unrecognizable in what amounts to evolutionary microseconds. And that leads to a darker question. If we can force evolution into overdrive in the crops and pests around us, what happens when climate change reshapes the entire planet? We're rewriting the rules of chemistry and atmosphere at a pace not seen since the Great Extinction events. We are recreating the very conditions that once set evolution on fire. The echoes are unmistakable. The Cambrian Explosion began in a world of unstable climate, chaotic oceans, shifting continents, and empty ecological spaces. Today, sea levels rise and carve out new shallow coasts. Ice melts to reveal raw land. Forests give way to deserts, deserts to wetlands. Planetary upheaval is becoming the new normal. Some scientists whisper about it. A second evolutionary explosion, not millions of years away, but close enough to imagine. We already see species rewriting themselves in decades, not ages. The machinery is there. Genomes with switches waiting to be flipped. Developmental programs flexible enough to invent new forms when pressed to the edge. And in the background, we hold tools Darwin never dreamed of. CRISPR gene editing has shown us how malleable the code of life really is. The line between natural evolution and human tinkering is starting to blur. So here you are, floating in that reef, watching ecosystems collapse and reassemble in real time. And it hits you. The Cambrian Explosion wasn't a one-off miracle. It was a preview of what life does when chaos opens the door. And we're opening that door again. Faster, harder, and more recklessly than ever before. The question isn't if evolution will respond, it's what kind of world it will create, and whether we'll even recognize it when it arrives. You're walking across the Burgess Shale in the Canadian Rockies, your boots crunching on rocks that were once the muddy bottom of a Cambrian sea. The mountain air is thin and cold, but you can almost smell the ancient brine. Feel the weight of water that covered this place 500 million years ago. Your fingers trace the outline of a fossil embedded in the stone beneath your feet. Marella, they call it, the lace crab, with its elegant head shield and trailing appendages preserved in perfect detail. The rock holds it exactly as it died, curled in what looks like a final moment of surprise. But here's the part that makes your skin prickle. This fossil was unearthed back in 1909, and more than a century later, paleontologists are still pulling creatures from these rocks that defy every category we've built. Each summer, teams return to these mountains, chiseling strange forms from the stone, life that looks less like it evolved here, and more like it was imagined by alien minds. The deeper we dig, the stranger it becomes. Above you, the wind whistles through jagged peaks, sharp and restless. It carries the scent of snow, laced with that faint metallic tang that always comes before a storm. And it feels right somehow to stand here, at the birthplace of Earth's greatest biological storm. A storm that raged 500 million years ago and left behind a record of creativity we still struggle to comprehend. The rock under your hand is smooth and dark, polished by millions of years of weather, but the fossil within it looks fresh enough to have died yesterday. This is what preservation in deep time looks like, moments frozen so completely that you can see the delicate branching of feeding appendages, the compound structure of alien eyes, the texture of shells that once gleamed in Cambrian sunlight. Your breath steams in the mountain air as you realize that somewhere beneath these peaks there are still fossils waiting to be found, creatures that will force us to rewrite textbooks, redraw evolutionary trees. and admit once again that the 20 million years of the Cambrian Explosion hold secrets we haven't even begun to uncover. The mystery isn't getting smaller as we learn more about this period. It's expanding, becoming more complex, revealing layers of strangeness that make the original question seem almost simple in comparison. We thought we were asking why evolution sped up. We're beginning to realize we should be asking why it usually moves so slowly. As the sun sets behind the mountains, painting the fossil beds in shades of gold and red, you can almost see them moving again, those impossible creatures swimming through ancient seas, experimenting with ways of being alive that we've never encountered before or since. Somewhere in Earth's deep history, for reasons we still don't understand, life decided to show off. In 20 million years that don't make sense according to any timeline we've constructed, it created a carnival of wonders and nightmares that still define every living thing on our planet. The Cambrian Explosion not only changed life on Earth, it revealed something about the creative potential lurking in the heart of evolution itself, a capacity for innovation and experimentation that remains hidden until the right moment, the right conditions, the right cosmic permission slip allows it to emerge. As you drift off tonight, let your mind wander back to those ancient seas, bubbling with impossible experiments in living. Dream of creatures with 5 eyes and grasping arms, of evolution drunk on its own possibilities, of 20 million years when Earth became unrecognizable to itself and emerged transformed forever.